We try to reduce attack surfaces where necessary. And then another aspect of that is the anti-tamper mesh. So it's this wire mesh that runs throughout the body of the device on the inside. If you were to try to crack the device open, drill into it, disassemble it in any way, you would short a circuit and it would blow out your chip with all your keys on it. So there is an easy way to back up your wallets, which I'll get into in a sec, but it prevents against physical attacks. In addition to just traditional hardware wallet types of functionality, we have this concept of remote signing, and that's based on permissions that the user would set up. So for example, if I want to allow Netflix to draw $13 or 13 DAI a month out of my account, I can set that up. If they were to try to draw more than that, it would reject the transaction, and it would reset each month. The other cool feature, probably my favorite feature of this device, is that we have, the user has access to very easy cold storage, backups and restoration using safecards, which are these. They just look like normal credit cards. It's actually the same chip that you would find in a lot of credit cards. And it's very good at storing secrets and doing all of the cryptography that we would need to utilize Ethereum, Bitcoin, any of the cryptocurrencies you want to use. And then the feature that I'm going to talk most about today that sets it apart is its wireless connectivity. So if you want to connect an application to this device, you go through this pairing process in which you exchange your cryptographic keys and establish a secure connection, which I'll outline a little bit. And this uses our SDK. So just some quick shots of the basic functionality. You have on the left our mobile wallet, which will ship with a device. It's going to generate a secret in order to pair, and then the user enters that secret out of band. Once the secret is entered, you can recover the key that made a signature on that piece of data from the phone, and you've established your paired secure channel. It's a hardware wallet, so it obviously does basic hardware wallet things like displaying a transaction, letting the user authorize. This is the default functionality, but again, recall that I mentioned permissions as well. And then the safecards. So using safecards is really easy. You can load them up with your currency of choice, and then in order to use it, all you have to do is insert it into a device, refresh your mobile app, and that's your new active wallet. OK, so the SDK is kind of the meat of this talk. It is a way to allow outside developers to build applications that would utilize this stateless and wireless signer, inherit all of the security properties of how the keys are held and how our signatures are made. It's a JavaScript SDK. So our mobile wallet that I just mentioned is built in React Native. You can use it with React Native, any server-side Node.js code that you want. I would love to get this in other languages in the future, but I just don't have the bandwidth at the moment. And then, yeah, it just exposes all the basic functionality, pairing, permissions, signatures, and whatnot. And we have docs. I'm going to go through a demo, but if you want to look at some of the functionality, you can go to gridplussdk.readthedocs.io. It's a lot more exhaustive than what I'll go through. OK, so to my right here, I have a prototype of our device. It is connected to the hacker Wi-Fi. And what I'm going to do here is just show you how you would get a basic app connected using our SDK. So you would import it. It's an NPM module. And you would, first thing you would do, if you wanted to use a network like Ethereum, you would have to set up a provider. So what I'm doing here is setting one up that's going to utilize Etherscan. And then once you have your provider, you put that into your client config. You specify, in this case, I'm going to specify an actual host. I'm going to hit this guy directly. But in production, we'll have a a cloud router of sorts, a proxy server that will allow you to connect based on a serial number, which you can use or not. You're always welcome to use a direct connection over LAN. And then you're just going to instantiate and initialize. So let me, don't have time to type all of this out, so I'm just going to copy and paste. Oops. Sorry, wrong window. OK, so this is all callback based. So after a period of time, you're going to initialize. That doesn't take any time. Connect is just going to try to literally just hit a route of this device. So now we know it exists. So the part that requires the user interaction is the pairing process. Recall that you would generate a secret. This one is not so secret and not so random, so probably don't do this. But you would generate a secret, give it to the SDK, and it would do all of the key exchange and handshaking under the hood. So when I do this, that's unfortunate. Oh, sorry, it actually did work. It's showing up on the screen here, and I would need to pin in. And so if I go back here, it'll show that it's paired. So again, recreate the secret, type it in out of band, and exchange keys. So now that we're paired, if we want to, the goal of this is to send some ether. What I would first do is get my addresses. So we use HD wallets. You need to specify a coin type, and you need to specify which indices that you want. So if you don't do anything, it'll just grab you a single address. But I'm just outlining it here. What this is saying is that I want to grab the first Ethereum address in my HD wallet chain, and I only want one. I'm getting bounced off. I'm not sure why. OK. I guess the Wi-Fi is a little shaky. So yeah, this will get my addresses. If I've posted this to a variable, so if I want to see what that is, that's my first address. If I were to request more than one address, it would return an array. OK, so this may or may not work, but it does give you the ability to get a balance, just using whatever provider you set up. So notice here I'm specifying ETH. I can blow this up a little bit too. Specifying ETH, and I'm giving it my address that I want to get the balance of. OK, cool. So that will get my balance. If I want to check that out, I can just go here. I can see how many transactions I've made, what my balance is. OK, so once I know what my address is, once I know that I have a balance, I would build this signature request, and I would make a signature request using it. This params block is what you'll probably recognize. These are just basic, like, since we're using an Ethereum schema, these are just Ethereum parameters. And you'll notice the schema code up at the top. So one of our design decisions with this thing is that we want to make sure anything getting passed and signed is highly structured. So in the case of Ethereum, that's pretty easy because you have the same fields. In the case, this one that I'm doing right here is an Ether transfer, so that requires the data field to be empty. We also have ERC20, and we also have an unstructured transaction, which would mean that you can specify whatever data you want, but it gets marked up to the user. But this is just a basic example, so I'm going to go ahead and do that. All right, it's my request. So now it's going to make a signature request to this device. So when I do this, the device is going to require me to authorize this on screen and then also pin in. All right. Super secure pin. So once I did that, it registers the signature. So if we were to look, oh, sorry, actually, we also have to broadcast this. So this is, again, just going to use that Etherscan provider. And it's going to broadcast this transaction hash. And, oops. There we go to Brave. So it's going to take a second to confirm. Once it's confirmed, I can go back and check the balances, make sure they've updated. Anyway, you get the idea. Yeah, so we have some bounties. In case anyone wants to build an application that, oh no. In case anyone wants to build an application here at ETH Denver that utilizes this thing, I've just showed you the basics of how to connect, how to request a signature. If anyone wants to give it a go, we have 3 bounties. The grand prize is 1,000 DAI, and then we have 2 runners up at 500 DAI each. The criteria is really just build any app that utilizes this thing. We'll choose the best 3. If there are only 3, we'll choose all 3. Some ideas would be MetaMask integration would be super cool. Chrome extension, so a password manager, for instance, or maybe something to interact with a Maker CDP. If you're going to do anything interesting contract-wise, you're definitely going to want to look at the ETH unstructured schema. This is all documented in our read the docs page, but that's what it's going to require you to do if you want to interact with contracts. Just a quick plug, as an aside, we also, Grid Plus has an energy business, which as of last week is live in the state of Texas. Yeah, cool. So what that means is that most Texans can now buy their electricity with ETH or DAI, or credit cards or ACH if you're so inclined. You can also redeem Grid to knock out all of the upcharge to get down to wholesale pricing, so you pay what we pay if you've redeemed those. So if you're in the Centerpoint or Encore regions in Texas, I encourage you to consider this. Go to gridplusenergy.com, sign up. We will be integrating this device on the energy side probably later in the year. It also has a Zigbee module, so it's capable of connecting to your IoT devices at home. I think there's a lot of cool use cases, but it also functions, as you've seen, as just a standard, or I guess above standard, crypto hardware wallet as well. So that's it. This is me. This is Grid Plus. Thanks for watching. If anyone has any questions, happy to answer. No questions? I guess if we have a couple seconds, we can check if that balance got updated. Oh, it did. Okay, so you can see it was starting with a 621 before, and it just took down a little bit. It did change. Yeah, it's a little smaller. Anyway, yep, that's our hardware wallet.
So quick question. What kind of IoT integrations are you most excited about?
The ones to start with in Texas would be your thermostat, smart thermostat, and your pool pump. The idea behind this to start will be that we have access to electricity pricing in a way that those device manufacturers do not in the state of Texas, because we're a regulated utility. And if we can see a price spike in formation, we can, if the user allows, we can actually turn off their thermostat, turn off their pool pump, and they won't like you get really ridiculous, like very short interval spikes, like in 15, 30 minutes. And in the Texas summer, 3 in the afternoon, if you're not home, you probably don't care if you just turn off your thermostat for 30 minutes. It could save you a pretty significant portion of your bill. So that would be where we start. And that's called demand response. Anything else? Good. Oh, one more.
Do you guys have any plans for the price point of the device or how you're going to do distribution yet, or is it not that far?
We have thoughts. I don't want to commit to them in public, but we do want them to be competitive with somewhat similar devices. So there are devices that look similar that have displays, right? So we would want to target somewhere around that level. But yeah. Oh, one other thing that I forgot to mention is also if you have grid tokens, where we think we'll probably give you a discount if you want to redeem those for the devices as well. And then distribution. The first run will be like a couple thousand, but it'll be kind of slow trickle. We have to commit to like 5,000 to 10,000 to start. All right, thanks everyone. Thanks.
Ain't nothing I can say.